Okay, I want to do a quick review of some Lewis dot structures, valence shell electron pair repulsion, and polarity of molecules. There are few elements that have less than octet. You have to know them. Hydrogen only needs 2 electrons, beryllium 4 electrons, boron, aluminum, they only need 6 electrons. The first example I go after is carbon monoxide. Now, if you do number of electrons that are involved, 4 valence electrons for carbon, 6 for oxygen, that's total of 10. So you have 5 pairs of electrons. And when you try doing Lewis dot structure, eventually this is the only structure that satisfies octet for carbon, octet for oxygen. Now, the shape of a molecule that has only 2 elements is linear. And bond angles, there is only 2 attachments anyway, it's 180 degrees. Now this molecule is polar due to electronegativity of oxygen. So it's a polar molecule. The other example is carbon dioxide, CO2. And then again you do your number of electrons involved, and eventually your Lewis dot structure looks like this, double bond between carbon and oxygen. Then again, you have 2 negative centers, the double bonds. They repel each other to be maximum distance away from each other. That's a linear molecule, 180 degrees. Now this molecule is symmetrical, so oxygens are pulling on the carbon, but in equal direction, therefore they cancel each other, and this becomes a nonpolar molecule. The other example I go after is hydrogen cyanide. Quite often you're being challenged on that. Now hydrogen only needs 1 bond, cannot have more than that, so we put that between hydrogen and carbon. And carbon and nitrogen, they don't have enough electrons, so triple bonding. Now then again, all you have is 2 centers that are negative. Whether you're single or triple or lone pair does not make a difference. They repel each other to become 180 degrees away from each other, linear molecule. Now this molecule is polar due to electronegativity of nitrogen and its direction, so polar. The last example for linear I want to give you is a polyatomic for, I give you NO2 1+. Now number of electrons for nitrogen, I have 5 electrons. This one I want to do it with you. 6 for each oxygen. I have 12 for the 2 oxygens. Now 1+, the cation indicates you have lost 1 electron. So I will subtract 1 electron from my total electrons. 5 and 12 is 17. Take away 1. You only have 16 electrons, or 8 pairs. When you do Lewis dot structure, it looks like CO2 again. Nitrogen, double bond to oxygen, 2 lone pairs for each oxygen. Since it's polyatomic, put it in a bracket, show the charge on top. And now you have 2 centers that are negative. They repel each other to make this molecule linear again. 180, and nonpolar since it's symmetrical. Then let's have a few examples of trigonal planar. So the first example I go after is boron trifluoride or aluminum trifluoride. They would have the same structure. Now remember, boron only needs 6 electrons. So you put 6 electrons, and then you saturate octet of fluorines. And it looks a molecule like this. Now this is a triangle, so the bond angles are 120 degrees away from each other. 120. And since it's on one plane, on rather XY plane, this is a planar. So we call this trigonal planar. And since all attachments are the same, this is nonpolar due to symmetrical shape of this molecule. Now if you change one of the attachments, for example, if you have formaldehyde, HCOH, Carbon is the central element, and oxygen will have a double bond, and the hydrogens will go like this. Then again, your trigonal planar, you have 1, 2, and 3 centers that don't like each other because they're like charges. They repel each other to form their triangular shape. So this is trigonal planar. Now this molecule becomes polar this time because the oxygen's electronegativity will win the game of which side of this molecule is the negative pole. So oxygen is the negative, hydrogen side is positive. Polar molecule. One other example, but this time I want to just have a lone pair going. So I'll go after nitrogen dioxide polyatomic 1- this time compared to other example on previous. Now let's just do our bookkeeping together. 5 for nitrogen, 6 for each oxygen, so you have 12 electrons. If you're anion, you should add 1 more electron. So 5 plus 12 is 17, plus 1 is 18. You have 9 pairs of electrons. When you do, one possible structure is this. Put it in a bracket, 1-. Now there is possibility for this double bond, the pi bond, to travel and go on the other side, so we call this a resonance. You show it with a line, double arrowed line like this, and you will show the other possibility as well when you're being challenged. The double bond is shorter than a single bond, and a resonance will have an intermediate value of the single and double bond. We worry about that eventually. But now the shape is a bent shape or V-shaped again. So bent or V-shaped. Now the lone pair has stronger repulsion, so it will force the single and the double to actually get closer to each other. This becomes about 118 degrees rather than 120. And it's also polar because of lopsided or asymmetrical shape. Now finally, I want to do 4 attachments on the central element. So I do one example of methane, CH4, carbon in center, then you have 2 hydrogens in the same plane. You have 1 hydrogen going, coming to you outside the plane, and 1 hydrogen going away from you. This is tetrahedron or tetrahedral, and the bonds are 109.5 degrees. And since it's symmetrical and every attachment is the same, it's nonpolar. Now what happens if you have a lone pair and 3 attachments? The other example that you should know is ammonia, NH3. When you do its Lewis dot structure, you would have a lone pair and then 3 attachments. Now the lone pair in this case will change the shape from tetrahedron to trigonal pyramidal. The bond angles will be between hydrogen, nitrogen, and oxygen would be lesser than 109.5. By 2.5 degrees, it's 107 degrees. And now the shape is asymmetrical. A pyramid is always polar. I can't say always, there is one exception. pH3 is nonpolar rather. Now, what if we have 2 lone pairs, such as water, which you should know? Then you have 2 lone pairs, 2 attachments. Now, this time the 2 lone pairs have even stronger repulsion, and the bond between hydrogen, oxygen, and hydrogen, 2.5 degrees, even lesser than that, is 104.5 degrees. Now the shape is a bent or V-shaped, and it's very polar. So these were few examples of Lewis dot structures of molecules that you need to know.